Here we have operations with polynomials. Our first example is when we're going to add and subtract here. All we're going to be doing here is just combine like terms. But right here we have this negative, which means we have to distribute to every single one of these terms, and ultimately it just changes the sign on there. So we're just going to drop everything down. We got a3b plus your a4 and 3a squared. And then now this is going to be a negative 2a squared, positive 2a to the fourth, positive a cubed b, and then the rest of our polynomial. And all we need to do is just combine like terms. So we'll just start from the left. We have a to the 3b, and then we have another a3b, and then another a3b. So what that is, we have three of those, and technically the coefficient on all of them is 1, so we're going to have 3a cubed b. Now, because we have so much going on, usually if you just cross them out, you know you've used it, and that you won't try to use it again. So now we have a to the fourth plus 2a to the fourth plus 5a to the fourth. So this is going to give us 8a to the fourth. And once again, just go ahead and cross them out. That way we're done with them. And then all we have left is a 3a squared minus 2a squared, which just gives us a positive a squared. And then this is our final answer for this one here, because we cannot combine any more. Now when we're multiplying them, when you're multiplying two binomials, the easiest thing to do is just use FOIL. Remember, it's going to be first, outer, inner, and last. So you're going to multiply them. Our first term would be 3x times 5x gives us a 15x squared. Our outer is going to be 3x times 8y. It's going to be a positive 24xy. Now, a general rule, since we have these two variables in this problem, go ahead and do it in alphabetical order so it's a lot easier to combine like terms. Now in here, we have a minus 5xy, and then our last term is going to be a minus 8y squared. Come across here, can we combine like terms? We can combine these right here. So drop down your 15x squared, and then you have positive 19xy minus 8y squared. And then this is your final answer. Now in this one, you have 2x minus 5 squared. Please never distribute this 2 into here, okay? That you have an expression here. So what this means is I technically have two of these, 2x minus 5. So we just go back to foiling. Our first term is going to be our 4x squared. Our outside term is going to be that negative 10x. Inside is a negative 10x. And then my last is going to be that minus 25. And then you want to combine these terms here. So you have 4x squared minus 20x minus 25. Now in our other example, when we had two binomials, we would always FOIL them. When it comes to anything higher than a binomial, so trinomial, polynomial, anything, the best thing to do is to use the box method. It's a lot cleaner, there's not so much crazy distribution and everything else. So we have a 2 and a 3. So your box is going to actually be a 2 by 3. So you're just going to create sort of a window pane as a box. You have 2 rows by 3 columns. So all we're going to do is just place these terms in each of our outside of our boxes. So we have our 5b minus 2, so 5b minus 2, and then you put the trinomial on top of here. So you have 7b squared, b, and negative 1. So now inside each of these boxes, all you're going to do is just take these two terms here and multiply it in here. So we have 7 and 5 gives us a 35. b and b squared gives us a b cubed. Then we have 5b times b gives us a 5b squared. And then 5b times negative 1 gives us a negative 5b. Now down here we have negative 2 and 7b squared gives us a negative 14b squared. And then we have a negative 2 and b gives us a minus 2b. And then negative 2 and negative 1 gives us a positive 2. So now we have all of our terms in here that we just have to combine. So 35b cubed, we cannot combine it with anything, so just drop it down. Then we have negative 14b squared and 5b squared. That gives us a negative 9b squared. Then our negative 2b minus 5b gives us a negative 7b. And then we have our positive 2 on the end. So it's sort of an easy, clean way to multiply anything over a binomial. Now, dividing by monomials. Now we have this polynomial divided by a monomial. Now remember, technically we cannot have negative exponents. What this means is that this term right here it's going to be brought down to the bottom of this. So this is now going to be divided by 4b squared. Now, the easiest way to do this is to break these up in 3 individual division problems. So you're going to have an 18a3b all over 4b squared. Then you're going to have a positive a squared b cubed all over 4b squared. And then your last term will be a positive 4ab all over 4b squared. And then you're just going to treat each of these individually. So 18 over 4 reduced is going to give you 9 over 2. Now, we can't do anything with this a, so just leave it on top. Now, b divided by b squared is b to the negative 1. Since it's negative, bring it down to the bottom. So this is our first reduced term. So now over here, we have a squared and it's 4. Can't do anything with it, so we're just going to leave it where they are. So we have a squared on top, 4 on the bottom. Now, b3 divided by b2 gives us ab. Now, in our last one, our 4's cancel out, and what happens is our a just stays up here because we can't do anything. Then we have b divided by b squared gives us a b to the negative 1, so you have b on the bottom. So now this is your final answer. You cannot combine any of these because you have different denominators, so just leave this as your answer. Now, on our last example, we're going to do long division. So this is going to go back to grade school with that whole divide, multiply, subtract, bring down, so forth. Now, whenever you look at this, you have to always check out your polynomials and binomials to make sure you're not missing any exponents. Meaning here we have x cubed and x squared, and then it goes down to our constant. So we're missing technically that x. So we need to make sure we fill in a 0 when we do our long division. So this is going to be out in the front of your division bar. So we're going to have 2x plus 3. Then you're going to draw your long division bar. And we're going to drop down all of this down here. So we have 6x cubed plus 5x squared. And then since we're missing that x, you're going to actually just put a plus 0x. So anytime you're missing something, you're always going to put a 0 in there. And the reason you want to do that is because it's going to fill in that spot and everything will line up. So now what we're going to do, we take this first term here and divide it by the first term here. So you're going to say 6x cubed divided by 2x. That gives me a 3x squared. Once when you divide first term with first term, you're going to go ahead and take this and multiply it through your binomial right here. So you got 3x squared times 2x gives you a 6x cubed. 3x squared times 3 gives you a positive 9x squared. At this point, you're going to go ahead and change your sign. So there's now a negative and a negative. So here, these will always cancel out. If they don't cancel, go back and make sure your division's done properly. So you have 5x squared minus 9x squared gives you a negative 4x squared. Then we're going to go ahead and bring everything down. So it'll be plus a 0x, because we need that space in there, plus 9. So now we're going to take this term again and follow the same steps. So we have a negative 4x squared divided by 2x. So we have a minus 2x. Take this, multiply back through. So we're going to have a negative 4x squared, and then negative 2x times 3 gives you a minus 6x. And then at this point, once again, we're going to go ahead and change our sign. So it's a positive and a positive now. So these cancel, and now 0x plus 6x gives you a 6x plus 9. Once again, 6x divided by 2x gives us a 3. Take this number, distribute it through. So 3 times 2x gives you a 6x. 3 times 3 gives you a positive 9. And then you're going to change the signs, so minus and minus. So what happens here, these all cancel, so you're left with a 0 remainder. So this is your answer right here. Now, what if we had a remainder? So let's say we did this over here, and let's say it equaled 4. You would write your remainder as a positive 4 all over what you divided by, so your divisor. So it would be 2x plus 3. So if you have a remainder, don't write r with that number. I want you to write as a fraction saying I have 4 over that 2x plus 3 left over.